Area of triangles. Area of a right triangle. The area of each of the right triangles below is equal to half the area of the rectangle. We know this because the right triangles are congruent. Congruent figures have equal areas, and the area addition postulate confirms that the area of the whole is equal to the sum of the areas of its parts. Since the area of the rectangle is given by A equals BH, the area of each right triangle is area equals 1/2 times BH. Area of any triangle. Now, let's find the area formula for an arbitrary scalene triangle ABC with base B and height h. Keep in mind that the height is always measured perpendicular to the base that is opposite the vertex. Now, turn this into the problem we did before. Frame a rectangle to surround triangle ABC with base B and height h. By framing the triangle in this way, B equals B1 plus B2, and the region now includes two smaller rectangles, one with the area B1H and the second with the area B2H. This makes the area of the shaded right triangle on the left 1/2 B1H and the one on the right 1/2 B2H. Note, B equals B1 plus B2. So the area of triangle ABC equals 1/2 B1H plus 1/2 B2H, which is 1/2 times B1 plus B2H, and then we do some substitution, 1/2 BH. Area of an obtuse triangle. In the previous example, the altitude of the triangle was in the interior region. There are occasions when the altitude cannot be drawn in the interior region. Let's look at an example. Is there an altitude from B to AC? No, but we can draw this one here from A to BC. The length of the altitude is the height. There are occasions when the altitude is in the exterior region. The construction below is evidence. Draw altitude BD to AC extended. Note, the length of each altitude is a height, but to different bases. Frame the triangle with a rectangle and label segments as shown. So here's our original triangle. We've dropped this altitude here, BD, and now we can make a rectangle that contains the triangle. So what is the area of region 2? Well, we have the area of region 1 plus the area of region 2 plus the area of region 3 equals what? Well, those areas all added together equal the area of this rectangle, which would be B1 plus B times H. So what can we substitute in here? Alright, so the area of just portion 1 here is 1/2 base times height, and in this case it's B1 is the base and the height is H. And the area for section 3 over here equals 1/2 base times height, and in this case the base is B1 plus B and the height is H. So how can we rewrite this? We've rewritten this by distributing that 1/2 in, so we have 1/2 base times height plus 1/2 base times height. So we now have 1/2 B1H plus 1/2 B1H, and those combine together to make 1 B1H because we have half here and half there. We still have this 1/2 BH here, so what do we have next? We distribute this, so this becomes B1H plus BH. Then what can we do here with this term? This term can be subtracted from both sides, leaving us with the area of region 2 plus 1/2 BH equals BH. So if we then subtract 1/2 BH from both sides, we get area 2 equals 1/2 BH. Theorem. The area of a triangle with base B and height h is given by A equals 1/2 BH. True or false? The area of triangle ABC equals 1/2 times BC, which is the base, times AE, which is the height. That is true. True or false? Area of ABC equals 1/2 AC, which is the base, times BD, which is the height. That is also true. So here we have created, we've substituted in this and this. So if both of these things are equal to the area, then we can set them equal to each other, right? That's true. So BC times AE equals BD times AC. All right, finally, true or false? The area of AEB, so the area of this triangle, equals the area of this triangle? Well, nothing that we've done has shown that this height bisected this triangle, or that these two triangles are congruent. We have no idea, so this is false.